Damping is the process in which energy is lost from an oscillating system by being transferred to its surroundings as thermal energy. Now, sometimes systems are actually damped for a reason to prevent the effects of resonance, and resonance is where, due to the periodic driving force exerting a frequency that is equal to the natural frequency of an object, the system begins to oscillate with ever increasing amplitude. And this can be bad, as shown by the Tacoma Narrows Bridge in the US in the 1940s. Now, the first type of damping is called light damping. This occurs when the time period is independent of the amplitude, so each cycle takes the same length of time as the oscillations die away. The idea is that the oscillations gradually get less and less and less, and it takes a long time, but eventually you will reach the point where it will reach the equilibrium position. Then there's critical damping, which is just enough to stop the system oscillating after it has been displaced from equilibrium and released. So therefore, this returns to equilibrium in the shortest time possible and doesn't overshoot, so there's no oscillation, it just returns to equilibrium in the shortest time possible. It's important in a vehicle suspension system, for example, as where you might have an uncomfortable ride if the damping was too light or too heavy. Then the final type of damping is heavy damping. This occurs when the damping is so strong that the displaced object returns to equilibrium much more slowly than if a system is critically damped. And basically you wouldn't really do this because no oscillating motion occurs, and the problem is that it will just go very, very slowly. For example, if you imagine a mass on a spring in thick oil, it will take a long time to actually reach the equilibrium position.